Let's talk about why we need custom hash functions. I'm going to introduce this seemingly by taking a total left turn into a totally different problem. And I'm going to ask you a question. Let's suppose that the equals method for colored number is what's shown here. That is, two colored numbers are equal if they have the same num. Now, if you don't remember this syntax, the way that this worked when we write an equals method is we first check to see if the other object is also a colored number. And if it is, remember this instance of keyword does a check of the type, and it also casts it as a colored number so that inside this if statement, other cn is a variable of type colored number. And then we'll check and say, is this number equal to the other colored numbers? Num. In that case, we'll return true. If they're not the same number, we return false. And by the way, if it's not a colored number, like it's a string or something, we would say false. Okay? That's how we're going to define equals. So what does that have to do with hash sets? Well, let's think about the following. Let's suppose we add the numbers 0 through 19 to a hash set, and these are colored numbers. And then we say, hey, hash set, do you have 12? Okay. What do you think will happen? What do you expect to happen? Okay. So what should happen, if our hash set is working correctly, is it should return true. We expect this contains call to be true because all 12s are created equals. That's the expectation we have. Just like any string that is the word cat should be equal, any colored number that has 12 in it should be equal because that's how we defined equals. Okay, it's based on just the num. So let's say that we're using the default hash function, which is just the memory address, which gives us this table on the right here. So for example, 2 is in bin bucket 0. And let's suppose that equals returns true if two colored numbers have the same num, just like we've been talking about. In this case, if we run this code, the exact code here, what will actually happen? Is this going to be true? Is it going to be false? Is it going to be something else somehow? Okay, so I'll let you think about that for a second. I'll give you a hint, which is the answer is non-deterministic. It's a challenging problem. Okay, so the answer is the contains operation will return false 5/6 of the time, and it will return true 1/6 of the time if you run this program. And the reason is, assuming that our colored numbers are given a random memory location, the basic idea is that because the hash code is based on the memory address and equals is based on the num, when I say new colored number 12, I don't know where it's going to end up. That new colored number could be in it could have an address that ends in 0, in which case it'll be 0 and so forth. The key distinction is to realize there's actually two different colored number objects. There's the colored number object that's referenced by the hash set, and then there's the colored number object that was created here when we did new colored number. So one of them is created when we do new colored number I when I is equal to 12, and there's another one when we call new colored number 12. Okay? And each of those memory addresses is random. And there's only a 1/6 chance that they're going to mod to the same bucket. So for example, let's say that the object that's created by this code has memory location 6000000, then its hash code mod 6 would just be 0. Okay? So in other words, when the hash set is doing the process of checking, does the hash set contain 12? It'll look at this object and it'll say, your memory location is this. I'm going to mod it by 6 to get 0. So I'm going to look in bucket 0. But there is nothing equal to 12 in this bucket, okay? So if that object that I create here on this line happens to have bucket 0, 2, 3, 4, or 5, we're going to miss it. But there's a 1/6 chance that we get lucky, and we just happen to end up in the same bucket, okay? So that brings us back to the question. If the default hash code gives us a good spread of items, like shown here, why do we need custom hash functions? Well, it's necessary that the equals and the hash code functions be consistent for operations to function. So in other words, if the hash code is based on the memory address, but equals is based on the num, there's no guarantee our hash code, that our hash table will work correctly. And so the basic rule is that if there's two objects that are equal, for example, colored number 12 and colored number 12, they have to have the same hash code so the hash table can actually find the object. Okay? So that's why we need hash codes. Even though the default hash code spreads things out evenly, if we have a type in our hash set where there's a notion of equality, we need the hash code to be consistent with that equals method that defines equality.